Is the audio and video clear?
Yes, sir.
Fine. So let me share my screen first. Yeah, hope the screen is visible.
Yes, sir.
So what were we discussing in the last class? We're discussing about superposition theorem, right? So what is the fundamental statement for superposition theorem? What we're discussing about superposition theorem? When you have a network with multiple sources, fine. What's the strength for today? P7. Okay. Once let me hear everyone. Everyone there?
Yes, sir.
Yes, sir.
Yes, sir.
Looks like it's
Yes,
sir.
many of you are inactive. Fine.
No, sir.
Yeah. Fine. Okay. So what is the statement given for superposition theorem? What was the basic statement for a superposition theorem? What's the need for using a superposition theorem in general? Or where do you use the superposition theorem, or how you use it?
Find voltage across an element.
Yeah, to find the voltage across any element, or to find the currents through any resistor or any element in the circuit, right? So we won't disturb the circuit, or we won't modify the circuit. So to simplify the calculations, we generally use theorems, right? Fine. So we were solving some problems in the previous class where we solved this problem. 1, 2. We are solving the third one as well, right? Yeah, we finished this, right?
Yes, sir.
Yeah. Let us take this example, which will be interesting to solve for many theorems. Fine. So find the voltage V across 3 ohms resistor by applying the principle of superposition. So I think we have dealt with these type of circuits previously as well, right? What happens if you have a circuit like this? What should be done first? Have you
It
seen
should
this?
be simplified too.
Yeah, we can redraw it, right?
Yes, sir.
Yeah, first what we do is redraw the circuit, right? And we will see how many sources we have and what is the connection of these elements, either they are connected in series or parallel, right? We find the currents using the superposition theorem later on. Fine. So how can you do that? What's the thing we can how can we, so just extend the circuit, how you can do the circuit? How can you redraw this? Can you redraw the circuit?
We can, sir.
Yeah. So try to redraw the circuit once. We will, once you got the circuit once you finish the redrawing the circuit, you will get to know what are the elements we have or how they are connected. See, this node can be extended somewhere here, such that these two are connected, 2 ohms and 3 ohms.
In series, sir.
They are connected in series across a 5 amps current source, right?
Yes, sir.
So we can bring this node somewhere here where you can draw these elements in parallel, these two in parallel, just like this, right? So you'll be having a line in between. So after redrawing that circuit, what's the first thing we have to do for applying a superposition theorem? Simplifying the circuit is to avoid your confusion. That's it, right? So what should be done in the step one? How many sources were to first thing to do in a
Sir,
superposition theorem?
isolate the current sources.
Yeah, we need to first identify what are the sources we have, right? So what are the sources we have in the circuit now? How many sources we have?
3, sir.
3. What are they? 2 current sources and 1
2
voltage.
currents and 1 volt.
Yeah. So what should which source? Let us consider this 4 amps as source 1, 5 amps as source 2, and 6 volts as source 3. Okay. So case 1, we assume that only source 1 is present. That is 4 amps is present, and we have to replace these other sources with their internal resistance. So what is the internal resistance of a current source?
The one parallel to it. Resistance parallel to it.
No. I said so replacement is nothing but ideally current source has an infinite resistance, right? I have to replace this. I'm just not drawing the equivalent circuit for that. I want this source to be replaced with its internal resistance or internal impedance, which will be definitely infinite value, which is nothing but an open circuit. That's what we are talking in the last class, right?
Yes, yes.
So current source here 5 amps is replaced with the open circuit, and this voltage source 6 volts is replaced with a short circuit, isn't it?
It is, sir.
So you're able to follow, right? So we need to consider only one source at a time. So in the case 1, what we are considering is 4 amps source acting alone, and the other corresponding sources has to be replaced with the internal resistances. So internal resistance of our current source is an open circuit, and that of a voltage source is a short circuit. So you replace them. Now what we have to do is to find the currents dividing here. So how the resistors are connected now in the case 1, when these two are not present, when voltage source is shorted and current source is open circuited, what is the current that flows through 3 ohms resistor? How can you find that?
Current division. Current division.
You apply the current division, right? So this is how it goes. Apply the current division. So current will be divided into 2 parts. So one part is the with resistor 1 ohm, and other is the path of consisting of resistors 2 and 3 ohms, right? So what's the current division rule? Total current into other branch resistance by total resistance. So this is what the current we get, right? Is this clear with the first case?
It is, sir. You can cut.
Yeah. So we are interested in finding the voltage drop across the 3 ohms resistor. So the current flowing through the resistor is known because these two are connected in series. The current flowing through them will be the same. So the total current is 2 by 3 amperes that is flowing through these two resistors. So we are interested only in finding the value of voltage drop across the 3 ohms resistor. So multiply the current and the resistance, we'll get the value of voltage as 2 volts. Right? This is case 1. Let us consider case 2 as well. So case 2, consider that 5 amperes is present, right? Only 5 amperes is present. So just like the 2 amps current source is, what happened to the current source here? First current source 4 amps. It is replaced by your internal resistance. What is the internal resistance? It's an open circuit, right? Now this current source we can divide. What the thing we have to do is to find the current flowing through this 3 ohms. So we apply the same principle here. But why did I take minus here? Why did you take minus?
Opposite direction.
Opposite.
Yeah. Direction is reverse to the previous one, right? So we wanted it. We ourselves took that since the direction is reverse, we assumed it to be minus 5. So how the current is dividing now? We apply the same principle that we need to find the current flowing in these 3 ohms, right? So total current into opposite branch resistance by total resistance. Right. So this is what you get as minus 2.5. Is it current? Okay, I will get a current here. What the value of current I am going to get here is here. Multiply with the resistor, you will get the voltage drop. So this is the equation for current, right? Minus total current into opposite branch resistance by total resistance. What's the value I'm going to get here? 5 by minus 5 by 6, right?
Yes, sir. Minus
Yeah.
2.5 is correct.
Yeah, minus 5 by 6 is the current that is flowing, and multiply that with 3 ohms, you will get the value of minus 2.5 volts. So this is a voltage drop when 5 amps source is acting alone, right? Yeah. So this is a case 3 where we assume that current sources are open circuited and we have only one voltage source in the circuit. Now we need to find the voltage drop across this resistor, right? Now see, when these current sources are open, how the circuit behaves like all these resistors are said to be connected in series, right? Is it okay with this circuit, with this equation?
Yes, sir.
So we don't have any other path for the current to flow. So whatever the current that is delivered by 6 volts resistor, 6 volt voltage source is made to flow through all these resistors. A same value of current will flow through all these resistors, so they are said to be connected in series. So we know that a series circuit acts as a voltage divider. So what is the equation we can apply for a voltage division rule? Is the total voltage multiplied with resistance divided by total resistance, isn't it? So we wish to find the voltage drop across a 3 ohm resistor. So we multiply the total voltage, that is 6 volts, multiplied with 3 ohm resistor divided by the total resistance of the circuit. What is the total resistance? 1 plus 2 plus 3, right? So what's the total voltage I am going to get is 3 volts, right? And based on the superposition theorem, what's the principle? What's the final statement for superposition? We calculate the responses through the element individually when the sources are acting individually and sum them, right? So what is the total response or what is the total voltage drop that is occurring across 3 ohms resistor is the sum of all the 3 responses, individual responses, right? In the first case, we found that the voltage drop across the resistor 3 ohms is 2 volts, right? We found that, right? This is how we found it. The voltage drop across the 3 ohm resistor when 4 amps current source is considered is 2 volts. Now, when it comes for second source is minus 2.5 volts, right? And when it comes for the third source, right? When it comes for the third source, it's the voltage we got is 3. So sum of all these 3 will be a resultant. We get a resultant as 2 plus 2.5 volts as voltage drop across 3 ohms resistor. Am I clear with this circuit, with the
Yes, sir.
procedure?
Yes, sir.
Yeah. So we will discuss one more problem and go for the next theorem. Fine. If you have any doubts, meanwhile, just let me know, right? Yeah. So find I naught in the circuit in the figure 9 using superposition and verify superposition theorem. So what am I using and verifying? We'll just check it. Fine. So what's the difference of this circuit with the other circuits which you already dealt with?
Current dependent voltage sources.
Yeah, we have a current dependent voltage source here. So what has to be done when you have a dependent source then?
To just leave it in the circuit.
Yeah, you just keep it there as it is and you just follow the procedure which we follow for the rest of the circuits, right? We are bothered only about the independent voltage source or independent current source, but not on the dependent sources. So what in general we do for applying superposition theorem? What has to be done? How many sources you have in this circuit now?
2 independent sources.
Two independent sources. What are they? One is current source of 4 amperes and a voltage source of 20 volts, right? Yes or no?
Yes, sir.
So what shall we do first? Let us consider these two sources, right? And let me consider 4 amps as source 1 and 20 volts as source 2. Okay. So once I do that, assume that case 1 where voltage 20 volts is replaced by a short circuit, right? And 4 amps is the only source which is acting now. So what will be the resultant circuit now when only source 4 amp source is considered? So this will be the circuit, right? This will be the circuit, right?
Yes, sir.
Yes, sir.
Fine. So what should be done next once you have a circuit of this kind? What you are interested is to find the current flowing through this 5 ohms resistor, right? So only when you have the first source, we can't directly apply the current division rule or something here because you have more nodes, more loops. So what should be done? We know what's the procedure for loop analysis, right?
Mesh
So,
analysis.
yeah, apply the mesh analysis and please let me know the values of I1, I2, I3 as quick as possible because you already know how to use the calculator for calculating this, right? We also discussed direct inspection method, how to write the equations, right? Yes or no? Are you able to write the equation? Will you be able to write the equations for mesh analysis? Yes or no? So you forgot the mesh analysis, right?
Doing, sir, one.
Yeah. So if I get some confirmation from your side, I will be waiting. So you are able to write the equations now. Before Bhaskar, are you there?
Yes, sir.
Fine. I was calling for you yesterday. Are you able to follow, man?
Yes, sir.
Is Dinesh available? Where are my favorite students in the group? Are they available? Yeah, who is that? Yeah, number 36. Are you there?
Yes, sir.
Yeah. Okay. Okay. So what is the equation for first for loop 1, loop 2, loop 3?
In loop 1 will be 4 ampere only, no, sir. Current in loop 1. I1.
Yeah, in current loop 1.
4 ampere, no, sir.
Okay.
Current source is given.
Yeah. Okay, fine. For loop 1, the current is 4 amperes, no doubt. Fine. So can get the value of I1 to be 4, right? Directly. You can use the same old method or conventional method to find the values of I1, I2, I3. Or you can do it directly. I1 is equal to 4. You can keep it as I1 is equal to 4 and write the loop equations for 2 and 3. That's it. No issues. You can go in any procedure. So you do the same old way. Fine. Because we'll come to conclusion easily. So can someone tell me the equations for I1, I2, I3? What's the values for I1, I2, and I3? For by default, I1 will be 4 amps. And what about the I2 and I3?
Sir,
Yeah.
while doing the while calculating for individual meshes in loop 2 and loop 3, both sides have to consider the voltage, current dependent voltage. Sir.
Yeah. Both sides, it's a common source, right?
Yes.
Yeah. Since the source is common for both, right? We are using different notations here, but you use your own conventional notations, right? Sometimes we use small i's, right? I1, I2, I3. So already I1 is 4 amps. What about I2 and I3? Can I get the equations first? Let us solve for.
Sir, for loop 2, I got minus 2 I2 plus 4 I3 equals 20.
4 I3 is equal to
20.
20. Okay, for loop 2, right? Okay. What about this third loop? So you replace this I0, 5 I0 with which value?
I3, sir, it depends on the current and third loop, no, sir.
Yeah. Somewhere you has to mention 5 I0, right?
Yes, sir, I took it in terms of I3. Can we not take like that?
Okay, it should be I1 minus I3 or I2 minus I3 minus I1, right?
I didn't understand, sir.
See, what is the equation how do you start this equation here in this, let's say loop 2? Starting from this source, you write it as
5
2I1.
I0.
Yeah.
5 I0 it is given as, no, sir.
Yeah.
And,
So let me write the first equation as 2I1 I2 plus 2I2 plus, and coming to this current source right here. So this one is, I'm starting from here. What's the equation I get? First one, 2 into I2, right? I assume it to be plus and minus here, isn't it? Are you able to see the screen?
it's showing the whiteboard.
You're not able to see the whiteboard?
Board is only seen, sir. But we can see.
You can't see this or PPT.
No, sir. Only the whiteboard is showing.
Okay, fine. Is it okay now?
Yes, sir.
Fine. So what's the equation? Just write the equation as I said, right? I'm not able to put it in the slide here itself directly. Fine. So what's the equation we can write here is 2 into I2 starting from here. So what's the next equation? Next term in the equation? Minus 5 I naught, isn't it?
Yes, sir.
Yeah, because it's a voltage source, we are least bothered about the direction of I1 and I2s, right? So what's the current that is flowing here? What's the term, next term after this? Is 1 into I2 minus I3.
I2 minus I3.
Yeah. Here, what's the equation I can write? 3 into I2 minus I1, or you can directly write 3 into I2 minus 4. That's what you can write, right?
Yes, sir.
Fine. You can solve it or simplify it and let us write the next equation as well for the loop 3. So we start from here, write it for 1. So what is the equation? It will be, term will be 1 into
Sir,
I2.
would I not be the negative of current in loop I3, sir?
Forget about the current because it's a voltage source, right? Doesn't matter where the current, whether the I2, I3, directions of I2 and I3, because it itself is the direct source, right?
Yes, sir.
So forget about the direction of the currents. We just, if it is a current source, then direction matters, right? Now we are least bothered about the directions. Let us start the writing equation for 3, loop 3. What is that? I1 into I3 minus I2. So we are going from plus to minus. So we write it as plus 5 I naught. Isn't it? And next one is plus 4 I3. And next one is what is the current we are assuming here? 5 into I3 minus
I3 minus I.
or I3
I1.
minus,
I1.
yeah, I3 minus 4, whatever. So you just solve them for getting I2 and I3 because I already have the value of I1 substituted as 4. So you need to find I2 and I3. Are you able to find the finalize the equations?
We get 2 equations and 3 variables, no, sir?
No. You already have I1, right?
Sir, in terms of I naught.
I naught. So you have I naught in both the equations. I think you can eliminate that, right?
Yes, sir. Yes.
Somehow you can eliminate it. You can find the currents. Doesn't matter. Or you can eliminate I naught in terms by replacing that the value which you have here. See, are you able to see this previous slide? So what is I naught? Is the current that is flowing in this 5 ohms, right?
Yes, sir.
So what's the current that flows in this I naught is assumed to be either I3 minus I1 or I1 minus I3. It could be anything. You can use them because until unless you have the equations in terms of I1, I2, I3, we can solve them for any number, right? Any equations.
Sir.
Yeah.
Sir, what will be the voltage across that current dependent voltage source, sir? Just to the left side of it.
Didn't get you. Left side of it at this point, right?
Yes, sir.
So whatever the voltage, see, since it's a dependent source, we are considering only one source at a time because the other one we shorted it, right? So what we are trying to do is we want to find the current which is flowing through this resistor here now. So once I go, we come to know the value of current that is flowing here, I can get the magnitude of this voltage source. Compared to this is just like a voltage source, right? It's just like a independent voltage source, but instead of giving it as 5 volts, we are giving with some constant here. That's it. So who defines this value of output voltage now? Is the factor X, right?
Yes, sir.
So this amount of current, that is whatever the value of I naught, current I naught that is flowing through this 5 ohms resistor, is to be found now. So what is that value now? To eliminate the to know the values of I1, I2, I3, I need not to have a fourth unknown value, right? That fourth term. So fourth unknown term is I naught. What is I naught can be written as? It can be either written as I1 minus I3 or I3 minus I1. Both suits better, right? Anything is okay. However, the value of I1 is known to be 4 amps. We already thought that since it's a loop current, the current here, whatever the current I get here is same as here, right? So that's, I can write it directly as I1 is equal to 4 amperes. Am I clear?
Yes, sir. Sir, but I
So-
started using KCL, sir.
Yeah.
I did not write loop equations, sir. I wrote KCL equations.
Okay, you can write with KCL, but what about the currents then? You need to identify the, you want to write in terms of nodal analysis?
Yes, sir.
Okay.
I considered that a junction of three points meeting, no, sir. That one as Z, sir. So then I naught will be Z by 5.
Okay. Yeah.
So I found it, sir. But my doubt is what will be the voltage just to the left side of that current dependent voltage source.
So you can't write that directly. So you can directly write as Z minus 5 I naught by 1. If this is the reference node. If you are considering this as reference, somewhere you have to add a reference, right? What's your
Yes,
reference
sir.
node?
I wrote it as Y, sir.
Here, this as Y, right?
Yes, sir. So that to the left side, will it be Y plus 5 I naught, sir?
Yeah, that will. You go, whatever the equation you write, you go in this way. This is Z, right? You wrote this as Z, right?
Yes, sir.
Okay, so equation, what will be the equation for current in this branch when you use a nodal analysis is, we write it as Vz minus 5 I naught, right? And minus Vy by 1 is, right, is the current which I get here.
Yes, sir. Okay, sir.
What are the current I have here? Say whether it might be I1 or I2 or Ix, I write it here like this.
Yes, sir. I got I naught as 5 by 37, sir.
Yeah, 5 by 37 here.
Yes, sir.
So it should be same for in mesh analysis as well.
Yes, sir.
Yeah, 49, you got this value?
Which one, sir?
Yeah.
Sir, I didn't get you, sir. I was not listening.
Yeah, what is the current you got here? I not. Are you
I'm
able
doing,
to
sir,
calculate?
1 minute. The equation.
Yeah.
Sir, minus 1.23.
Yeah, 2 point.
Minus 1.23.
Okay, you got it as I naught is equal to minus 1.23. Okay, let us see. Let's let them do the calculations. Any other answers other than this? 36, what was your answer? I naught as minus
No, sir. It is 0.1081 plus
1081. So any other answers either for 1.23 or 0.1 something? I think instead of going for nodal, you can directly go for mesh because you have only 2 equations and 2 unknowns, right? However, I1 is already known, so can easily find these two as well.
Sir, I got I3 as 6.66, sir.
I3. Okay, 6 point.
I think it might be incorrect, sir. The equation is not satisfying.
Yeah,
It's
which
2.76.
okay, which one?
I3.
Okay, 2.76.
76.
Yeah, it could be probably it might be the right answer because he got it as someone got it as minus 1.23. It will be addition of your value to this will be 4, right? So what's
Yes,
the
sir.
value? What's the value you got? I3 is equal to
2.76.
okay. I3 I can write it as I3 is equal to 2.676
76.
amperes, right? Hopefully that might be a because addition of these two will be the 4 amps, right? Which will be satisfied in this loop. So is that the answer? I can 36. Can you check the your answer once again, or can you verify that with the KCL?
Yes, sir, I'm doing that.
Okay, I3 is equal to 2.9. Okay, so I2 is 13 amperes.
So 1.42.
I2 is 1.42.
Yes, sir.
Okay, I2 is equal to 1.42 amperes. So before that, see, if everyone want to be okay with the expressions, let us write the expressions for these two, right? So just help me in the writing the equations for mesh. I think someone has followed with mesh analysis, right? We can do for both. I'm not hesitate. I'm not saying that we can't use nodal analysis, but okay, if it is so, we can use it. But I think
Sir, I got it, sir. I3 value is correct only.
2.176 amperes.
I got 2.22 though, sir. And
Fine,
it's close.
fine. Let us see. Let us see here. I wish to give the solution, man. Well, let us write the equations directly. It is taking more time, right? Let us do this. What's the just help me in writing these equations and correct me if we are wrong, right? So what's the value for I1 I have is 4 amperes, and we write the second loop equation, right? So what's the equation I have? I can write is 2I2 minus okay. What's the next one?
5I0.
5I0 next plus 1 into I3 minus I2.
I2 minus I3.
Yeah, sorry. I2 minus I3. Yeah. I2 minus I3. Next plus 3 into I2.
I2 minus I1.
I1, or I directly can write it as 4, right? That's okay, right?
Yes.
Okay. So this is equal to 0. So simplifying this, what's the value we are going to get?
6I2.
Okay, we will directly write it. If you have done it, that will be easy for me. Okay, 6I2
Minus I3.
minus I3. Okay,
Minus 5I0.
minus 5I0.
Minus 12 equal to 0.
Okay, is equal to 12. Okay, let us write this as equation number 2. As equation number 1. This okay. Is this fine?
Yes, sir.
Okay. Let us write the same equation, similar equation for loop 3 then. So starting from here, let me start from here, this space. Okay, so what's the equation we can write here for this is 1 into what's the equation I write? I3
Minus I2.
minus I1, sorry, I3 minus I2. So I can write this as plus 5 I naught, isn't it?
Yes, sir. Plus
We are going in reverse, right? So plus 4 I3, right? Next one
5 of I3 minus I1.
plus, okay, 5 of I3 minus I1 or I3 minus 4 I directly write is equal to 0. Fine. So solving this, what's the equation we are going to get?
10 I3.
What's the value? 10 I3. Okay, 10 I3
Minus I2.
minus okay 10 I3 minus
I2
I2
plus 5 I0
plus 5 I naught
minus 20 equal to 0.
minus 20 is equal to 0. Okay, equal to 0 I write 3, right? So I can use equation 2 and 3. Can I add them or subtract them? Add 2 and 3. What's the equation you are going to get? So what's the equation we are going to get if I add these two? So in terms of I2, I'll get it as 5 I2, isn't it? Or can we, shall we use directly for some
So
replacement?
the other equation is also there, na, sir.
Which one?
I not equal to I3 minus I1.
Yeah, let us use choose any of these then. That will be fine, right? Instead of doing this, okay, let us substitute it common for both then. That will be fine, right? The equation will become more simpler then. So let us use that I naught is equal. What's the equation we can write for I naught is equal to?
I3 minus I1.
No. What's the direct in the circuit? Was it in the same direction in the question? Was the circuit same in the question? See, this was I naught, right?
Yes, sir.
Yeah. Let us see. Now here it is.
We got I2 as minus 6.7, sir. Would that be correct?
What's the value? Roll number. I'm getting some disturbance from somewhere else. Who is that? Roll number 56. Okay. So what is that I naught? I can replace it with, since the direction we assumed was this, right? So if this is the direction that was assumed, so we already have that I1 is in the same direction, and I2, I3 we are assuming it to be reversed. So I can write it as I1 minus I3. Will that be appropriate? I1 minus I3. It should be appropriate, right? If I write I naught is equal to
Yes,
I1
sir,
minus
it would.
I3. So
I took I3 minus I1.
whatever, it should get it as negative then, no issues, because I write it as 4 minus I3 now. So wherever I see
Yes,
I naught,
sir.
I can substitute it as 4 minus I3. So these equations change now. Now equation 3 and equation 2 gets changed, right? Now what's the equation that is going to be the equation 2 has to be modified to what value? So what's the modified equation for 2? This value remains same, 6I2 minus what's this value? 5 into I naught, right? So 5 4s are minus 20, right? And I3 minus of minus, you write it as plus 5 I3, and I already have minus I3, so I write it as 4 I3. That is equal to 12. Is that okay?
Yes, sir.
So I can send this 20 other side, so I can write it as, what's the equation I can write? 6 I2 minus or plus I3, okay, is equal to 32. Equation number 4. That will be fine, right? Is that okay?
Yes, sir.
Okay. Similarly, we substitute the same thing in the equation 3, where the values change here. So I can write it as minus I2 plus 5 4s is 20s and minus 5I3 with 10. So I have plus 5I3, right, which is equal to 20 now here. So this 20, if I send there, it will become 0. So I get a equation as minus I2 plus 5I3 is equal to 0, equation number 5. Is that fine?
Yes, sir.
Okay, can you solve these two equations and get me the value for I2?
So directly we can substitute I2 value in
Yeah, that will be also fine. That will be also be fine, right? So from this you can write I2 is equal to 5 times of I3. So take this as equation 6 and substitute this in the equation. What is that equation we wrote? 4. So what's the value we're going to get? 6 into 5 I3 plus 4 I3 is equal to 32. So 30 I3 plus 4 I3 is equal to 32. So what's the value of I3 could be? 32 by 34.
2.94.
32 by 34, right?
Yes, sir.
Okay.
0.94 ampere.
0.94. Okay. So what's the value for I2 then? Substitute that and tell me the value for I2.
It 0.18, sir.
Okay, 0.18. Is that okay with the I2? So what's the value for I0 then? It's almost 3.06, right?
Yes, sir. 3.0.
Then that's fine. I think is that values for this case okay? Let us write the final values here. I1 is equal to 4 amps. What's the value of I2? Is 0.18 amperes, right? Because we will be needing of these values later on. I3 is equal to 0.94 amperes. And what's the value of I0? I0 is not required, but we generally write it 3.0.
3.04.
Okay, fine.
I2 is 4.7. No, sir.
No. We got it as 0.18. I2 is, what's the value got?
I2 is 5 I3 now, sir. 5 into 0.9.
Okay, fine. Wait a second. Yeah, sorry, man. Right. So what's the value here? It should be 4.7. 4.7. Sorry, yeah. This was wrong, right? So okay. This is 4.7, right? 4.7 amperes, and I think this is the same direction where this is flowing. Then it should not be 4.7, man. Then it should be 4.94. Then 4 times, or see, what's the product of this? 5 into 0.94. Into 0.94.
That is only 4.7.
4.7.
4.7 only.
Okay, 32 divided by 4.94, right? .94 into 5.7. Then how can we justify that this is okay? Fine. This is about I0, right? Not about I. I is different. I0 is different, right?
Sir, I solved it again, sir.
Mm-hmm.
Sir, I solved everything again, sir. I got I2 as 36, sir.
I2 as 36.
Oh, sorry, not I2.
I3 as
I0 as
3.087.
Yeah, 0.8.
I3 equals to 3.087.
With the same, are these equations okay, or there is any problem with these equations?
Equations are same, sir.
The
But
equations
values
are same,
different.
fine. Then where did we miss it? We just substituted and got the value, right? Yeah, row number 12, it's 2.76. What's the justification? Okay.
Sir, I also got 2.76 one.
Sir, but
Yeah.
solving the equations, getting the answer 3.087, sir. I3 equals.
I3 equals 3.087.
0.08.
So someone got 2.76 as well. But if these are the equations, then I directly get this value. Where do I find it wrong then? Did I do any mistake here when writing this 2020 or finalized equation is this, right? The final equation, are the equation 5 and 6 okay? 5, 6, equation number 4, are this okay? 4, 5 and 6. Is there any problem with the equations? I3 is equal to minus 32. Okay, I0 is equal to 36.
I did it with KCL, sir.
Okay, fine. What are the method? The procedure remain, the values remain same, right? Whether you go in that way or this way. What happened? What about others? Is that the values you are going to get, or
Then one solve using these 3 equations, sir.
which equations? Which 3?
2 and 3, and other one is I0 equal to 4 minus I3.
Yeah, that's what I said, right? This was already substituted somewhere. I think might have done some mistake in this substitution. If at all I can do something wrong, I can do only at this point.
If we solve these 3 equations, then we are getting I3 equal to 2.76.
Okay,
Below
fine.
equation to 20 shouldn't come.
Yeah, that's I send it here, right? 20, I got it here, I send it here. So on the right hand side, it will be adding.
Sir,
From where did you get the 20, sir?
sir, I think
Can you please
that
once
20
again?
will not get cancelled. I think you cannot get that 0, sir. I think somewhere it went wrong. Minus or plus sign.
Yeah, that's what I feel
Because 20 is
I
getting
got in
cancelled,
that
no, sir.
equation
One
40 as the
equation.
coefficient, sir.
this has 40, right? That's the problem where it
Yes,
is
sir.
coming, right?
40 you
Okay.
will get that one.
Okay, then let me see here. Let me see here as okay. Was the equation minus or plus here then? This plus 5 I know I wrote. Plus 2 minus, and it taking it as plus. Doesn't matter whether it is. Okay, I not I took it as 4 minus I3, so I will get it as okay. See, this equation is okay, right? This is fine, right?
Yes, sir.
So substitute this value here. I naught is equal to 4 minus I3 in this, and tell me the equation. We'll get I2.
Sir, always, sir, by solving 2, 3 and I0 equal to 4 minus I3 in 3 variables, we can get I0, I1, I2 and I3 now.
Yeah, that's what I said. I use any method, you will get the same thing, right? It doesn't matter whether it is with loop 1 equation or I naught equation. Since you have 3 equations and 3 unknowns, you should get the values of variables, right? I'm worried to open go for the next slide because it is taking much time for, or it looks harder for me to write the values here. Wait a second, if I wish I can write. Okay, so tell me who those who got 2.7 and as answer, just give me this value equations, whether they are right or wrong, just tell me.
6 and
Is this okay? 6 plus 6 I2 plus 4 I3 is equal to 32. Is that okay? Or
Yes,
is
sir.
it
Yes, sir.
is it minus here?
No, sir. Correct only.
Okay. What was the next equation that was used here? So this one, equation 3, where I wrote it as 10 I3 or let me solve this first. So I3.
5i3
Yeah, what's the equation? 5i3. 5i3
minus i2
minus I2.
equal to 0.
This is okay, right? I too got the same one, but is that okay? But the values with that are not correct. Is the substitution okay here? I0 is equal to 4 minus I3. Are we using it in the same manner? 36, you used it as I3 minus I4, right?
Where, sir?
You use this I0 as I3 minus 4 or 4 minus I3?
4 minus I3, sir.
Okay. Then you should also get this. Okay, fine. Use
Sir,
not-
I0 equal to I3 minus I1. If we take only, we'll get 2.6.
But anyway, the direction it should be same, right? Magnitude should be same. Whether it might be a polarity difference or direction. How can you take what is the equation you said?
I0 equal to I3 minus I1.
But okay, that is also fine because see, if I apply KCL here, what's the equation I'm going to get? Sum of incoming is equal to outgoing. I1, I0 plus I3 is equal to I1 is the equation, isn't it? So I1 is equal to I0 plus I3. So if at all I want to write I0, what's the equation I write? I1 minus I3. I wrote it as I1, you got it as 4 minus I3. That has to be, it should be fine, right? So what's the conclusion then? There should be at some point we need to conclude ourselves, right? So what's the values we conclude with? Somehow we can get the values in the next, because it's not the complete procedure. It has not been completed, right? We have done it only for one source. We can has to do it for the other source as well in the same procedure, right? But
Sir, if we add this I3 and I0, we are getting 4 only.
which one? These here values which you have here. Huh?
Yes, sir. Yes, sir.
That's what we say. We found out these values from this itself, right? How did you get this value of I2? Did I get? We are not getting this in terms of I2 is not bothered, right? We are least bothered about this. I think these values look good, man. Let us see whether they are right or wrong then. Okay, so what are the values for I1 we have is 4 amperes, I2 it's 4.7 amperes, I3 it's 9.4 amperes, and I0 is 3.06 amperes.
Sir,
Is
that
it okay?
I3 equals to 3.087 and I0 equals to minus 0.913 also satisfying, sir.
Yeah. Let us see. If problem is that if this I0 changes, everything changes. That's the problem. We are getting multiple values here because it's not an independent source, right? So since this being a dependent source, what if there is any change here, then this changes. So
Sir,
when
here I3 is dividing, no, sir.
which one, where at which point here?
There itself. Yes, sir.
But you also have incoming current from I0, right? No doubt a difference of current flows here, right? I0 minus I3, or else I can directly say that this value of current which is flowing here is difference of I3 minus I1. Isn't it? If I have two currents from at one node, and the third current will be difference of the other two, right? Depending on the direction of current. Is that okay?
Yes, sir.
Okay, I think it's 4 I3 and not 13 I.
We took it as 4 minus I3 on this.
4 minus I3 we took, right?
So that only we took.
Okay, fine. So let us see. Let us fix ourselves with these values and let go for the next step. Then let us solve it and see. Is this okay? Just note on the values aside. Those who have different values or those who don't have the values, just follow the procedure. This which is given here, the equations here, and take these values. I1 is equal to 4, I2 is equal to 4.7, I3 is equal to 0.94, and I0 is equal to 3.06. Is that okay?
Yes, sir.
Yeah, we'll go for the next one now. As for case 2, so what should be done in the for the second case? Now, what's the assumption we make now? We assume that
We open the current source.
yeah, current source is open, and we assume that we have only a voltage source here, and we write the equations for this as well, right? So how many loops you have? Is I have only 2 loops, so you can directly write the 2 loop equations and 2 unknowns I4 and I5. You can get the values for I4 and I5. So let us not waste the time. Let us write. Help me in writing the equations now. Directly we'll write and solve it. So 2 into I4, right, minus 5 I0. I'm not using. Okay, let it be double dash plus 1 into I4.
I4 minus I5
Yeah, I4 minus I5
plus 3 I4
plus 3 I4 is equal to 0. Is this okay? Is the equation okay now? Tell me here itself, just we will modify if required, right? So what's the equation I have? 3 I4, 4, 5,
6 I4.
yeah, 6 I4 minus 5 I0, right? Let it be just like that. Okay, next, what about this? Minus
I5.
I5 is equal to 0, right? Okay, let us take this as equation 1 of the equation, first one. And let's go for the next one. What's the next loop equation will be? I start from here, okay, in this clockwise direction. So I take it as 1 into I4, sorry, I5 minus
I5
I4.
minus I4.
Yeah, so I took it as minus there, as I take it as plus here, I0, 5 I0, right? Plus 4 I5. So what's the equation I write here? I'm going from plus to minus. So what's the convention I'm taking? Minus to plus, I'm taking minus. So 20 plus, sorry, what's that other equation? 5 into I5 is equal to 0. Is the equation okay? I1 into 5, I4, 1 into I5 minus I4 plus 5 I0, and this is 4 into I5 minus 20 into 20, and this is 5 into I5. Is that okay? So I5, 4, 5, 5, 10. So you can write it as 10 I5 minus I4 plus 5 I0 is equal to 20, right? Equation number 2. Is that okay?
Yes, sir.
Now, wherever you find I5, what's the equation we have to replace this? Because this is I double not, I not double not, right? So at this junction, there is no division of the current happening. So whatever the current comes in this path is the same in this. So I can write these two are equal, right? Can we assume that I not I double
can
not?
be equal to I5, sir.
Yeah, this is the third equation. So substitute the same in equation 3 and 1 and 2 as well then. Is that okay? Can I assume that I not double dash is equal to I5? Because we don't have any other option, right? Is that okay? Minus 5 I0, or instead of I0 I'm using I5 minus I5 is equal to 0. So
I4 and I5 are also equal.
I4 and
I5.
how?
I4 equal to 6I5.
Yeah. So if I substitute it here, what's the equation I'm going to get? 6. Okay, 6I4 is equal to 6I5. Right. Let it be. Might be the values might be same. 6I4 minus 6I5 is equal to 0. And what's the next equation if I substitute it here? Will I get the same equation here as well? No, no.
Both will be equal, sir. 1.8 and 1.8.
So
Both
10.
currents.
So 10I5, or else I can write it as 15I5, right? 15I5 minus I4 is equal to 20. Is that okay? Here.
Yes, sir. We can find.
Okay, so what's the value I'm going to get? Can I substitute?
1.8 will be the answer for both currents, sir.
14 equal to 20.
Or else I4 is equal to I5 is equal to what's the value I'm going to get?
1.42.
Is that okay?
It is 1.8, sir.
You're getting two different values, sir. How can you get two different values?
Before
Because-
equation I4 is equal to I5, no, sir. Substitute directly.
Yeah, you just substitute it here. What's the value I'm going to get here?
14I5 equal to 20,
Yeah.
I5 equal to 20 by 5.
Yeah, 14I5 is equal to 20. You get the value of I5, that's 20 by 14, right? So what's the value for that? 20 by
1.42, sir.
1.42. Yeah. So is that okay? 1.42.
Yes, sir.
Now what? Okay, in these two cases, so what should be done next in general? Now, yeah. So we have assumed that case one, that only one source is present, that is current source is present. We have found the value of I0, and what we are interested in finding the value of I0, right? So what's the equation we wrote for I0 in the first case? What was the value in the case one when you consider only one source? I0
It is 3.06, sir.
is equal to 3.06 amperes. And in this case, when you assumed I double dash,
1.42.
1.42 amperes. So what's the resultant of these two? According to the superposition theorem, what's the total current? I0 is equal to the sum of
1.6.
I0 dash plus I0 double dash. So what's the equation it will be? What's the value? 4 point?
1.64.
Are you subtracting them? Okay, fine.
Yes, sir.
Yeah, so this will be, I can write it as minus then here. That will be fine. I0 1 minus I0 double dash, right? So what's the equation I get? What's the value I get? So instead of writing I1 not plus this, I write it as minus, right? Minus I0 double dash. Is that okay? Why did I take minus? Because in the second case, the current was flowing in this direction. In the first case, the current was in this direction. Because we took it as 4 minus I3 in the first case, right? So what's the value here?
64.
1.64 amperes. Is that okay with for everyone?
Okay.
Copy the values. So this is how we solve for using superposition theorem, right? So how you verify them? In the question it is asked use superposition theorem and verify superposition theorem. So how do you verify that? What is the procedure for verifying?
We find voltages across each element.
Or else use the same, by using source transformation, or you can directly use a KCL node mesh analysis or nodal analysis and find the values and verify that if I0 is equal to same 1.64 amperes, where we directly get the value, right? And may it be lengthy, but we can do it for verification itself, verification process only. Fine. So let us, shall we move on to the next one?
Yes, sir.
Okay. So we'll discuss about Thevenin's theorem. So this is one of the fundamental and important theorems, just like superposition theorem, right? Where a whole in the what do we do in that superposition theorem is that we will just calculate the value of responses individually and sum them up, right? If I have two sources, I'll calculate. I will assume that each source is acting alone. I'll find the responses, and finally I do a algebraic sum of them for DC circuits, and say that the total current flowing through that element or the voltage drop across that elements as the sum of the individual responses. But coming to the Thevenin's theorem, the theorem is stated as that any linear two-terminal circuit can be replaced by an equivalent circuit consisting of a voltage source in series with the resistance, right? So whatever the complex circuit, whatever be the complexity of the circuit, we can replace that whole circuit with two elements, that is a voltage source in series with resistance, right? So how do you calculate that voltage source now? The magnitude of that voltage source. It is we can calculate the open circuit voltage at the terminals, right? And the equivalent resistance is found across the two terminals when the sources are turned off. It means the statement itself means that we can replace any complex circuit with fundamentally with two elements. Suppose if I want to find, or if I wish to find the current through some element, right? A resistor which is present in a 10 element circuit. So we can, instead of calculating it for whole circuit, right? Only the two things are required. One is to find the open circuit voltage and the equivalent resistance, and we can build a new circuit, right? A new circuit where we can directly find the value of voltages and currents, whatever that is required. So let me give it in a quick example, right? So how can you do that is, suppose see, I have a complex network here. Let me assume that I have some, if this is a two-terminal circuit, right? Let me give an example for this, as suppose I have a circuit, right? I have some sort of circuit which is very, very complex, or whatever. What are the number of elements I have here? Let me give it in some case like this. Let these two terminals be this, right? These two terminals, you can assume that these are the two these two terminals, right? But I'm not interested in the whole circuit, but I'm interested in finding the current across in this resistor. So I consider this as RL, this as load resistance. Let me assume this as load resistance. So by using Thevenin's theorem, what we do is, instead of using this complex circuit for analysis, what we do is we replace this with only two elements. One is the equivalent voltage source, right? What you call it as Thevenin's equivalent voltage, connected with a series resistor, which is called as Thevenin's equivalent resistance, right? The whole circuit is replaced with these two elements now. Across which resistor? Across the same load resistance, RL. The same resistance I am using here. Instead of using the whole complex network, I am using only two elements. One is a voltage source and another is a equivalent resistance. So this circuit, you call it as Thevenin's equivalent circuit. So what is the statement for Thevenin's theorem? Thevenin's theorem states that any complex network can be replaced with a equivalent voltage source in series with Thevenin's equivalent resistance. So how do you find that equivalent voltage and equivalent resistance? Equivalent voltage is found across the open circuited terminals right? If at all I want to find this VTH, where do I find it? I find it across these two terminals where the load was connected. Am I clear? So let us solve some problems for this and we'll come to know. But before that, let us see what for which circuits we can apply it for. So the definition itself is this. Thevenin's theorem states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a voltage source VThevenin in series with a resistor RTH, where VTH is the open circuit voltage at the terminals and RTH is the input or equivalent resistance at the terminals when the independent sources are turned off. Right? So while calculating the value of VTH, we open the load resistance and find the voltage across that. And how do you find RTH? RTH equivalent resistance by assuming by finding the input resistance, right? Looking back into the circuit by when the independent sources are turned off. And what happens when you have a current source or dependent sources? We can let it go, right? We are bothered only when you have a independent sources. So let us see, and this is applicable for linear circuits. That's what I mean in the statement. Linear bilateral networks, right? So let me just let us take some examples for this that will be better for understanding. One second, give me a second.
Sir, you're muted.
Fine, thank you, fine. Okay, let me consider this circuit for making you understand simply, right? So I said that I have two parts in the circuit. Now what is that? Let me divide this into, this is a resistor in which I wish to find some value. Say I'm interested in calculating the value of load current. Let me say that the current flowing through this resistor, just like other values as well, right? So let me consider that this is a 10 volt source and these resistors to be 2, 4, 6, right? And let these two resistor be 5 ohms, right? Some similar for example, right? I want to make to understand what actually V does, right? So this is a complex circuit, right? Assume that this is it's not actually complex. Let us assume that this is a circuit, complex circuit, which is given for you. So what do we do in what's the equivalent we are going to get, or what you are supposed to get is, now according to the Thevenin statement, what's that? The whole circuit has to be reduced to a simple circuit which consists of elements. What are the elements we have in the Thevenin's equivalent circuit? What is the equivalent elements? What are the elements that has to be present in a Thevenin's equivalent circuit? First is one is RTH, another one is VTH, and what is the third one is RL. So let us assume that this is a terminal A and this is terminal B. Are you following?
Yes,
A,
sir.
B. Don't worry, I will give a break for 5-10 minutes in between once I finish this Thevenin's theorem, right? Before solving the problems.
Thank you, sir.
Okay. Now, see, right. So I want to now. What's my intention is to replace this whole circuit. Okay, this circuit mottani has to replace with only two elements. What are the elements I want? Is Thevenin and Thevenin. Yeah. So how do I find Thevenin now? What is Thevenin definition across according to the definition? What is Thevenin? It is the open circuit voltage. Okay, across A and B. Across A and B, or else I can write that VTH is nothing but VA. So where is VAB now? This across these two. That is across these two. So what's the value? What are the voltage I get here across A and B? That is equal to open circuit voltage. Am I clear? So if at all I want to get to open circuit voltage, I need to remove this RL. So what's the equivalent circuit when I open the RL? When I remove the RL, how will be the circuit now? The circuit will be just like this. See, I have a 2 ohms resistor just like this. So now this is A, this is B. So what is this now? 2, 4, 6, and 10 volts. Now calculate the value of, can you calculate the value of voltage drop across A and B? How can you calculate the value of voltage drop across A and B? Someone there? Can you find the value of voltage drop across A and B, VA and VB? Sorry, VAB. So V is equal to IR. What is I and what is R here now? Which resistance has to be considered now?
Thevenin's resistor.
Hmm?
Thevenin's resistor we have to consider for that.
Yeah. RTH, we have to consider RTH, no doubt, but we are not going up to RTH. We are finding VTH now. Okay, we wish to find VTH now. So what is that VTH we are going to find now? How can you find it?
First, we have to remove the potential drop due to 2 ohms resistor. Then we'll get
Okay.
voltage across that. Then we have to subtract potential drop across 4 ohms resistor.
Okay, can we do it in some other way? See now, since this is open circuited, what is the where is the how many loops of current are possible?
One is possible.
Only one, right? So this is I1, right? Is there any current flowing in 4 ohms? Is there any
No,
current flowing in 4 ohms? Now I think we can redraw the same circuit like this, right? 2 ohms and 6 ohms. This is the voltage source, right? So this is 2, this is 6, and this is what are the voltage I have across? This is the voltage drop VAB, right? VAB, isn't it? Can I reduce the circuit like this? Why did I omit 4 ohms? Why we are neglecting the 4 ohms resistor?
No current passes.
Yeah, since there is no current flowing in the 4 ohms, we can ignore it. So what are the voltage that is what are the voltage drop that across 6 volts 6 ohms is going to occur? It will be the open circuit voltage, right? Am I clear? So what's the voltage drop VAB could be then? VAB, what's the value of VAB will be 6 into current, right? If I assume that I have a current flow of I1 here, right? So what's the equation I can write is 6 into I1. So what's the value of I1 now? How can I find the value of I1? 6 into total voltage, that is 10 volts divided by 2 plus 6. Is that okay?
Yes, sir.
So what's the value I'm going to get here?
7.5.
7.5 amperes. Amperes or volts?
Volts.
Also,
Yeah. You can get it as 7.5 volts, right? VAB. How did we get to this conclusion of VAB is equal to 7.5 volts? Nothing. What we have done or what we has to do is remove this load resistance first to find the value. What's the first step? To find the VTH, what is the step procedure 1? Is remove the load resistance across AB, right? Now remove the resistance across load resistance and find the voltage drop across A and B. So how to get the value of voltage A and B? How to get the voltage drop across A and B? Since there is no current flowing in the 4 ohms resistor, right? The current only flows through 2 and 6 ohms. So now I need to find the value of current that is flowing through 2 and 6, which I assumed it to be I1, right? So now whenever there is a flow of current through 6 ohms resistor, there will be a voltage drop. What is that voltage drop I am going to find? It to be 7.5 volts, which will be considered as VAB. Now since we got VAB, which we can write it as VTH, right? So what's the Thevenin's voltage now? What is the open circuit voltage across AB or Thevenin's voltage we got is 7.5 volts. First task finished, right? So I got the value of VTH as 7.5 volts. How did I find that? Can someone tell me how did you find?
Sir, open circuited the terminals of the load and found the.
Yeah, we just find the value of voltage that is appearing across A and B. That's it, where the load resistance was removed. Was that okay? Is that okay? So how to find RTH then? What's the procedure to find RTH? See, okay. You want some statement for this? Let me read it out then. See, what is VOC? The voltage VOC is equal to the potential difference between the terminals A and B caused by the active network, no external resistance connected to these terminals. That's what I did, right? We removed the external resistance and we found the open circuit voltage. Now, RTH, what is the RTH? Is the series resistance or equivalent resistance looking back into the network from the terminals A and B with all the sources made inactive or dead. So now when I come for our circuit now here, see, in our circuit, what is it? What we assume this is RL, right? Now, in order to find the value of RTH, we have to look into back into the circuit. And what should we do with this voltage source then? What should be done for the voltage source? Should it be there or should it be replaced with something else?
It should be short circuited.
Yeah, voltage source have to be short circuited. So what's the equivalent circuit will be when for finding RTH? So for finding RTH, so what's the equation we have to write is something like this. Diagram 2 ohms, 4 ohms. This is A. This is a resistor, and this is shorted, right? And this is. So what is this value of resistance? 2 ohms, 4 ohms, and 6 ohms. Okay. So what is the value of RAB here now? Now what if I find RAB, then it is equal to R mean, right?
5.5.
How do you come to 5.5? Now how we ignore 4 now? Ignored 4 here, right? But we can't ignore.
No, sir.
What does it mean by looking into the circuit?
Sir, we
Looking
can ignore 6 ohms.
which 6 ohms? Yeah, see, looking the definition itself means that we need to look back into the circuit, right? Looking back into the circuit is nothing but assume a current flowing from here. So what will happen if the current flows up to this junction? Whatever the current I send, that will be same in 4. But at this junction, it will be divided into 2 parts, right? So again, it comes back here, and this is the node where it comes back. So when there is a splitting of current and coming back of current, I say that these two are how 2 ohms and 6 ohms are connected now? Parallel. So I can find the equivalent of that, right, as something like this. So
Sir,
this
but-
is A, this is B, this is 4, and this is 2 parallel 6. Sir, someone asked us have it
Sir,
out?
but current will pass through the less resistance, no sir, less resistance path.
Yeah, but it doesn't mean that there will be no current in 6 ohms, right?
Okay, small amount of.
Yeah, the current magnitude we can have the current division I into opposite branch resistance by total resistance. It will be in the ratio of 1:3, right?
Okay.
Yeah. So what is the equivalent I am going to get here now? 2 parallel 6. 1 point. Is that okay?
1.5.
Yes, sir.
Yeah.
1
Now
point
these two.
1.5.
Yeah, these two are connected in series. So what's the value of RAB now? RAB is equal to 4 plus 1.5
5.5.
5.5 ohms.
So now we got the value of 5.5, right? Now I got the value of so this RAB is nothing but R Thevenin. So now I got the value of R Thevenin as 5.5 ohms. So instead of using this whole complex network, more complex even, we can get to these two terminals or these two values. One is VTH and one is RTH. We found the value of VTH or VAB across the open circuited terminals A and B, right? And we got as 5.5 ohms. How did you get to this value? By looking back into the circuit, open circuited terminals. So we need to look back into the circuit from open circuited terminals, and then you find the value to be RAB. Or now what should be done now? You construct the Thevenin's equivalent circuit now. So what's the equation I can give? What is our intention? What was the intention mean? What's the voltage? What's the current that is flowing through RL, right? So what's the equation I can give for IL now when I have a Thevenin's equivalent circuit? Voltage by equivalent resistance. What's the voltage I have? V Thevenin by R Thevenin plus RL. Why? Because these two are connected in series. So what's the value I'm going to get for IL now for this circuit? What's the value of VTH?
10.5 by 10.5.
7.5 by 5.5 plus 5.
That will be 0.71.
0.71.
Yeah, 0.71 amperes. We can even verify this. So to get here is the current I'm getting it is 0.71 ampere. Since I have considered a simple example, this would be much better, easier than this, right? But once you get habituated, we can even solve complex problems, solve for complex networks as well. Is that clear for solving a problem? Okay, take a 5 minutes break. It's 3:30. Join back after at 3:20 at least, right? The recording will be the class will be like don't exit, just be there, right? But I will start. I continue the class from 3:20. Okay, take a 5 minutes break.
Yes, sir.
Sir, should we short even current dependent voltage sources, sir? In Thevenin's analysis.
Okay. So let us, shall we solve one of the problem?
Sir, we'll try solving the previous problem with Thevenin's analysis.
Previous problem is?
With Thevenin's analysis.
Okay, same example of previous. Which one? The
That's
last problem.
I not know, sir.
Yeah, previous one. Okay, let us go do the same thing then. We already have some data for some values, right? So we'll do the same here.
Copper produces a current in the circuit, and then next chemical reaction can be represented as follows.
Okay, thank you everyone. See you tomorrow.
Thank you, sir.
Thank you, sir.